know, we're not going to worry about it because we're not going to jam anything else in. You do need to know the parametric and you need to know the rectangular. Those will both be on your exam. Okay. But you don't need to worry about polar. All right. We are going to move on to 9.9. Did we all get our essential question written down? Do we need a minute? Take a minute if you need it. Read it to yourself as well. All right. Let's go through those two things really quick. Michaela, can you read us the essential question? Awesome. Matthew, can you read the I can statement?
I can calculate the area of a region bounded by 2 polar curves.
Awesome. We're not going to do 2, okay, instead of just 1. And it is more likely if it's on the free response to see this, okay? And when we get back from break, that's what we're going to hammer is we're going to start hammering free response questions. We're going to take a week and just do free response questions for a week, basically. I'll probably give some quiz. We'll do little quizzes throughout the week, and whatchamacallit, we will make sure that polar is part of that. So that's how I'm going to test you on polar is polar and parametric. We're going to put in little quizzes and free response. All right. So we got to find the area of the region between 2 curves. It says find the area of the region common to the 2 regions bounded by the following curves. R equals -6 cosine theta and R equals 2 minus 2 cosine theta. So the picture is somewhat deceiving, okay? What we want to do is we want to find the area. Don't highlight what I'm going to highlight. I'm just going to show you because we're going to kind of scribble all over that picture. What we're trying to find is the area of the region they have in common, meaning where are they both? So that means that I'm actually finding the area of all of that. Okay. So we're going to use the kind of technique where we find the area of half and double it because it might just be easier than finding the area of the whole thing. If I have to find the area of the whole thing, I have to split it into 3 different integrals. If I do the area of just half, I can get away with 2 integrals. Okay. So let me explain the 2/3 integrals. So I would pick a color if you've got colors. Okay. Let me pick. I'm going to go green. So right here, I'm going to do this top half. Notice that my curve is the black circle, right? So if I'm taking my little can of spray paint and I'm spraying all the way up to that 2 pi over 3 is just the area of the black circle. Okay. Then hopefully you notice it changes, right? Right at 2 pi over 3, it changes to the cardioid. All right. And if I was going to take my can of spray paint now, what I am hitting is the cardioid. Okay. So do you see how there's 2 different integrals? I could go all the way around to here, and then I'd have to do another integral on the circle because it's not continuous. Okay. And it's not continuous over here. So it's probably easier to do the split it in half thing. All right. So we're going to use the same area formula as we used yesterday. Okay. So I'm going to go area equals. All right. So I'm going to do what had to go in front of the area. Good, 1/2. And we're going to double this thing. So I'm going to go 2 times 1/2, the integral. All right, now our picture is going to be a big assist here, okay? If I had to and I didn't have it labeled on the picture, could I set the 2 things equal to each other? If I set the 2 things equal to each other, it should give me these other points of intersection, okay? So I'm going to skip that since it's the Friday before spring break and they gave it to us, but it is possible to set them equal to each other, okay? All right, what is my first place, the first value that it hits or that it starts? in radian. Right here. Yeah, it's starting at pi over 2 because you got to think of that picture, even though the picture isn't like completely complete. Think of it like the unit circle. This is 0 radians, and then it goes up to pi over 2, and then it's going to keep going. Okay, so our bounds are going to be our angles, our radian measures. Okay, so I'm starting at pi over 2. All right, where does my green spot end? What radian measure does it? Doesn't it end here? 2 pi over 3. All right, and then we take our whatchamacallit, we take our R value and we square it. Now here's the tricky part. You have to know which is which, okay? So this would be handy to have our calculator and be able to do it in our calculator, or if you know at least enough that the cardioid is going to be something plus or minus something, that you know that the cardioid is second and the circle was the first one. So we're just going to go with the fact that hopefully we know what it is, or we have our calculator, because we're going to use our calculator to integrate anyways in a minute. All right, let's go plus. All right, and then I'm still, I should have put this in parentheses there. Okay, I'm still going to double. I still have to do 1/2 the integral. All right, what are the bounds this time? Where's the pink region starting? Where's my first point on the pink region here? Yep, 2 pi over 3. All right, and then it's going to keep going, 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 going. What radian measure does it stop at here? Good, Stephanie, pi. All right, so then I've got this 2 minus 2 cosine theta. Oh, what a squared d theta, right? Okay. Let's talk about actually typing that into our calculator. Okay. We're working smart and not hard on the AP test. Okay. What can I do some canceling right there? Yeah, don't the 2's cancel here? So do I really need to type in the 2 times 1/2 part? Can't I just do my integrals, square it, and we're good? Okay. Let's, for just practice sake, let's put both of them into R. That's our good habit. Okay. And then we will do the integration from there. So we're going to put the green one into R1 and the pink one into R2. Because you never know, you might have to use it more than one time in a free response problem, so then you've got it typed in already. That's good practice. We haven't practiced doing the R's much, so let's practice the R's. So I'm going to go menu. I'm going to do doc B, actually not menu, doc B. All right. The first one was -6. Oh, that's not where I want it though. That's function, isn't it? Menu, graph, edit, entry, polar. -6 cosine theta. And hit enter. And then my second one, 2 minus 2 cosine theta. All right. Give you a couple more seconds there, and then I'm going to go back to my calculator page. All right, so we're going to go menu, not menu, calculator page. Calculator page. How do I get an integral? Shift plus. Okay, and then we know it goes, and I can type the pi into that little spot there, so we know it goes from pi over 2 to 2 pi over 3, right? was our first one. 2 pi divided by 3. And then our first one was in R1. So I'm going to go to var R1, and you're going to use thetas because that's what it was in. Theta, and then you want to square that. D theta. I don't know if I need parentheses around. Let me see if I get the right number. 1.63. Did they give me? Oh, I may need to square that, or I may have done that wrong. Hang on, let me see. Use their same. Oh no, they did a 1/2 on it. No, we're good. We canceled in a different spot than they did. All right, do the same thing. Oh, I didn't mean to do that. Guess what? I should have done it all in one step, huh? That was silly of me. Let me copy that and try that again. There's nothing that says I can't put plus and do the other integral, right? I should have done that. All right, I'm going to do shift plus again. And this time it's going to go from 2 pi over 3 to pi. And then we're going to go var R2 of theta. Don't forget to square it, d theta. There we go. Much better than was it yesterday? The power reducing, right? Having to deal with all of that and all the U subs. We at least did the harder part yesterday. The harder method yesterday. All right, 15.707. Okay. Give you a minute to mess with it, and then we'll do the next one. And then it looks like we're going to have time to play Gimkit, which would be kind of fun and nice. And I have a non-calculus one today, too. Okay. All right, let's look at the second problem. All right. Take a minute, read it to yourself, okay? Okay, the good news is they were nice enough to tell us that the circle was r equals 2, right? So we didn't have to worry about which one was which. We already know that this is this thing right here, okay? And that this one is the, whatever this is, Limacon probably in the background. And what we're trying to find is the shaded area there, okay? It means that we're going to go from here all the way around until we hit here. They did not give us the bounds this time, so they weren't quite as nice as it could have been. So it probably wouldn't hurt us to probably figure out what those are. It's good practice, so let's try that. Just one black screen. Okay, so let's start by doing 3 plus 2 sine theta equals 2. All right. What do I have to do to move the 3? Did I lose? Oh, there it goes. Okay. I lost connection back on this screen, but it looks like it's going there. But it's being really slow and delaying here. Okay. So 2 sine theta equals -1, right? Sine theta equals -1/2. So we need to know the two places where sine theta equals -1/2. So what quadrants would I be in? Yeah, we're going to be in 3 and 4. All right, so I'm going to go -1, 0. 0, -1, and maybe 1, 0. Okay, so I'm going to work with my y. I know I've got to go 1, 2, 3. I need that one right there, right? So what radian measure is the one that's just after pi? Do you remember? So this would be, what was it? Yeah. Think of it as 6 pi over 6, right? So this has got to be 7 pi over 6. So we know that one of them is 7 pi over 6. Okay. If I come down from this one here, I know that that's going to be my negative 1/2 there. So is it that way? Yeah. What would you say, Stephanie? 11? Yeah. 11 pi over 6. But there's a little bit of there's a slight problem with that one. Okay, but we'll get there. Just I lost my second screen here. Let me fix that up. Okay. And move that back over. Okay. All right. So the catch with that is if I put 7, so don't write this quite yet. Okay. So if I put 7 pi over 6 there and 11 pi over 6 here, as I am traveling around, can I count 11 pi over 6 and then do 7 pi over 6 and I just erased everything? I can't count like that, right? That's not the way counting works. I have to have something where I can count in order because it doesn't make sense to say 11 before I say 7, right? Yes, we're going to do the negative. So what is it coterminal to? Yeah, good. So we can go negative pi over 6 and integrate all the way to 7 pi over 6. Okay. The last example, we added the two areas together. Doesn't this look like we're taking this is somebody's head taking a bite out of that cookie? So what operation do you think we're going to do this time? Yeah, we're going to subtract. Okay, so we're going to subtract the two areas. So we have to make sure that we put the right one first. So it looks like the green area is going first, and then we're going to take the subtract out of that purple area. Okay. All right, the formula is no different. I'm going to go ahead and do the half thing again. All right, so technically I'm not even going to need to use the 7 pi over 6. If I did the half thing, what radian measure is right here? What's our radian on the vertical axis there? Yeah. So I'm going to choose to go pi over 2, and I'm just going to find this half of it here. Okay. All right, so which means I'm doubling. So 2 times, what's the formula start with? 1/2 the integral from negative pi over 6 to pi over 2. And I'm doing the green one first. So the green one was the 3 plus 2 sine theta. What do I have to do to that? Good. And then minus, we're going to do the 2 again out front, right? And let's see, I'm doing purple. So 1/2 to 2. The integral, same bounds. Negative pi over 6 to pi over 2. And then it was 2 squared d theta. So when I put this in my calculator again, could I just ignore my 2's and my 1/2's? It kind of makes it a little bit less calculator strokes. Okay. All right. I'm going to give you a minute. I want you to try to put it in on your own. Okay, so you put it in on your own. Then I'll start doing it. Oh, I know why. Double check, see if we both got the same thing. $24.187.
Yeah.
We agree? Okay, perfect. All right. 24.187. Awesome. Okay. Lost it somewhere over here. Pull this back this way. All right, you guys want to play Game Kit? Fishtopia?